Hi everyone, my name is Cristo Armando. I'm the SI for Organic 2. So every Thursday I have a SI session in Hayes 203 at 7 p.m. So we went over our first SI session last Thursday, and I'm just gonna let you know that I do a video for each SI session for those of you that can't go. And um, I'm gonna work out the problems, 20 problems in total each week, or more, or a little bit less. So let's get started. So this is our first reaction plus HBr, and I'm going to be drawing the reaction downwards just because it's easier for me. So first thing that this reaction is going to do is that a double bond is going to attack the hydrogen molecule. This bond right here is going to go to the bromine, and we're going to form this intermediate. Also, I do want to apologize for the messiness. I do not have my pin yet for my iPad. So you have this intermediate, but remember we do have that Br, which now has a minus and 4 lone pairs, and it's going to add on right here. So the final product is going to look something like this. So I would highly recommend that before I solve the problem, that you try to solve it. The first 10 of these problems are just a recap of the reactions from Organic 1. So that was problem number 1. So now problem number 2. So in case you don't know, those lines just signify that it's a carbon with 3 hydrogens or a methyl group. So each line just signifies a methyl group. Plus HCl. Right. So the same thing as the last reaction. And because the molecule is symmetric, it does not matter where the hydrogen adds on to. We have the same intermediate, and again we have a halogen with 4 lone pairs that's going to add on, and our final product is going to look something like this. Alright, let's go on to our next problem. Okay, so problem number 3. It's similar, except that the carbon on the right is only going to have 1 methyl group and then 1 hydrogen. Again, the reaction is going to proceed very similarly. Double bond is going to grab the hydrogen. Then this bond is going to go to the iodine. And for the reaction intermediate, it is very useful to understand that the iodine is going to add in a Markovnikov faction to the most substituted carbon. So that means that the hydrogen is going to go to the least substituted carbon, which is the carbon on the right. So our intermediate looks something like this. We have this positive, and then the iodine is going to attack this carbon. And so our final reaction, molecule is going to look like this. Again, the iodine adds the Markovnikov fashion. So to the more substituted left carbon with the two methyl groups instead of the right carbon with just a single methyl group. So now for our fourth problem, we have this symmetrical molecule plus this. So we know through the past three examples that bromine, chlorine, and iodine all react. But fluorine does not react. So this would be just no reaction. Pretty easy. All right. Problem number 5. Okay. So, same mechanism as before. Double bond grabs the H. This bond goes to the iodine. And again, it does not matter where the iodine goes because the carbons involved in the double bond are symmetrical. So this could have the two hydrogens. This could have the single hydrogen and then the plus charge. And then in this case, the iodine would add right here. And our final product would look like this. Oops. All right. So now we're going to go to problem number 6. Problem number 6 looks like this. Okay, so in this case, the acyl halide is gonna undergo a similar mechanism as before. The bond is gonna grab the hydrogen. This bond is gonna go to the bromine, and the major product intermediate is going to look like this. Well, it's more useful. Draw this hydrogen right here. And then we have the bromine. And it's going to add on right here. So, as in problem number 3, this is going to add in Markovnikov fashion to the most substituted carbon. Okay. I forgot to name that, my bad. That was problem number 6. Okay. So problem number 7. Name that right there. Plus this. So a very similar mechanism. And in this case, both carbons are secondary, which means that they both are attached to 2 other carbons. So the major product is basically both of the molecules that occur. So to simplify it, I'm not going to draw the intermediate. We know how that mechanism goes. But I am going to draw the 2 different products. So this is the first product. So in this case, iodine's going to go right there. And for the second product, we have this. The iodine is going to go right there. So these are in 50% and 50% concentrations in the solution. So both products are made in equal concentrations. Okay. Now we're going to go to problem number 8. And I'm going to start drawing it a little bit more normal. HCl, which is our acid catalyst, and we're going to have water. And I like drawing water like this, knowing that it has those 2 lone pairs right there. So this is a little bit of a different reaction in that it's 2 steps. So I'm going to try to be as thorough as possible on this example. So what we are going to have here is double bond going to grab the H, and the bond between the hydrogen and the chlorine goes to the chlorine. And our first reaction intermediate is this 2 positive right here, and a hydrogen right here. And right here you might be thinking, why does the carbon on the left only have 3 bonds to it? Well, right here, that's the hydrogen. I didn't leave it out. But whenever a carbon just has like the 3 bonds attached, we just always assume that if it does not have positive charge or negative charge, then it has 4 bonds attached to it at all times. So after this occurs, you're going to have the same mechanism as before, where the halogen is going to attack. Oops, you know what? I actually did this reaction incorrectly, because the hydrogen is not going to attack that one. It's a Markovnikov addition, so the hydrogen would have attacked the less substituted carbon, and then the halogen is going to attack the more substituted carbon. So we're left with this. Right? And so the second part of the reaction is basically going to react with water, right? Again, I like drawing it like this. Double bonds of water gonna attack this carbon. This chlorine is gonna leave, as it is a better leaving group. And we end up with this molecule plus the chlorine, which left. Okay, so this mechanism is going to be used for the next couple of problems. Wow, I do not know why these dots won't go. Okay, problem 9. Oh, that's really big. Okay, problem 9. We have the same mechanism, because we're again gonna have first our acid catalyst, except this time we're going to be adding this into the mix. So what happens first? We know that, and we end up with reaction intermediate looking like this. And then you have the chlorine, the 4 lone pairs that's going to add on to here. So now we've established that, right? We end up with product that looks something like this. And we have this H3. So what's going to happen here is that, again, the lone pair is going to attack this carbon. This chlorine is going to leave, and we're going to be left with a second intermediate in this reaction. CH3. And now we have the oxygen here with the methyl group and with the hydrogen. So it's going to have a positive charge because usually hydrogen likes two lone pairs and two bonds, but it's not having this right now until a water molecule just comes and takes away this hydrogen, thereby giving back the lone pair here. Ooh, that's really ugly. My apologies, guys. So we end up with this product for our final product, CH3. Again, Markov-Nikov addition. The oxygen with the methyl group is going to add to the more substituted carbon. Alright. Oops. Okay. So the 10th problem is a little bit more complex looking, but it's just the same mechanism that we've been doing in the past. Right? Where we're going to add the acyl halide, HBr, and we've done this reaction multiple times, right? So I'm going to skip the intermediate that's formed, and since this is a symmetrical molecule, the bromine is going to add to whichever. I always keep on drawing this double bond here. And let's choose this side. So the important thing to note here is that we form two stereocenters from the alkene. So stereocenter number 1 here and stereocenter number 2 here. Alright, so those were the problems I wanted to review for organic 1 of the alkene reactions. The next set of 10 problems are review from last week's lecture on alkene reactions. So let's get started. Problem number 11. So Br2. So what is going to happen here? So when you have Br2, we can also just think about it like this. And so the same thing is going to occur that has been occurring. Same mechanism, but instead of the hydrogen, we just have one other bromine. So I'm going to draw the intermediate. We have a positive charge here. And then the other bromine is again going to add right here. And finally, our product looks something like this. Right? So what do we have here? Something called a vicinal. I'm not going to try spelling it out. A vicinal dihalide. Okay, let's go on problem number 12. Okay, problem number 12. That may not be clear. So let me draw a little bit bigger. That's a little bit better. Plus Cl2. I'm going to draw it just like that so it can be a little bit more convenient for some of us. So again, double bond grabs that chlorine. That bond goes to the other chlorine and we form I keep on drawing the bond. Form something like this. Right? And just like we have been learning before, the other chlorine is going to want to attack right here. And the interesting thing to know here is that they're going to add opposites. So while this one is coming at you, this one is going to add away from you. Right? Moreover, you can also create it the other way, like this. This one going away, this one going out. And these are just called enantiomers, as we learned in class today, and as we learned in Organic 1. Okay. So let's keep it. All right. So problem number 13, we have something like this. So again, the same mechanism. And we have something interesting happened here. Actually, before I forget it, yes. Before I forget it, there was a mistake on the mechanism for the last problem. I'm not going to redo it just because I can correct it here. So, what I forgot to note is that this is going to form a bromine bridge, right? And I do apologize for that mistake. But again, we have this bromine right here going to attack right here. This bond goes to the other bromine. And just like the other reaction, we have one coming out at us, and we have one going away from us. Then again, we have this molecule on the left plus its enantiomer, right? So again, I do want to highlight that when you're going to add a halogen to, I'm sorry, well, let's just keep it like that. Okay, problem 14. We have something similar. Right? So going to have this bromine bridge. And then the bromine's going to add here. This bond goes to the other bromine. And so we end up with this molecule. Right? But we're also going to end up with this molecule. Now, it's probably easy to assume that these two molecules are enantiomers, but they actually aren't. They're actually identical molecules. Because if you flip the molecule on the left, about 180 degrees, right? If you flip this molecule, then what ends up happening is I don't even know how to use this program, so I'm gonna leave that there. What ends up happening is that it's gonna look just like the molecule on the right, so they're actually identical molecules. Sorry guys for all the technical glitches and stuff. This is my first time recording. I'll be sure to be a little bit better next time. Luckily, this is our second to last reaction problem. So, problem number 15, we're going to have carbon, hydrogen, 2. And this is actually a reaction that we recently went over in class. H2SO4 and H2O, right? So, I really wish I would have drawn that a little bit differently. So, H2SO4, the double bond is going to grab this right here, functioning like an acid, and we're going to be left with the following intermediate, CH3, with a plus right here. And the water molecule right here, let's break it down like this, is going to add onto this carbon, and we're going to create our second reaction intermediate. Looks something like that, with the extra hydrogen. So what's going to happen here is that another water molecule is going to come and get this hydrogen. This bond goes back to the oxygen, and so we're left with our product. I just realized this is supposed to be an alkene. Sorry, guys. Sorry about that. Sorry about that. And we're left with this product. And then this molecule undergoes tau taumerization to give us this ketone. Bloop. Just one. Okay. I'm hoping to make this process a little bit more clear in the final problem. So, oh my. Oh my. Oh my. Sorry, guys. I guess it's been a long day. I don't even know where my homepage is. Okay, there we go. Okay, our last problem. Let's end this on a good note. So, the problem number 15 was supposed to be an alkyne like this one, just like this one. So, right here we're going to have pH3 and THF, And then we're going to have H2O, H2O2. So the mechanism for hydroboration, oxidation, is a little bit above me. We went over it in class last Thursday, so I'm not going to go over it. But what I am going to note is that it functions in essentially the same method that hydration functions. So I guess now would be a good time to draw out question number 15 again, which was just like this, except it was H2SO4 and H2O. So in reaction 15, we saw that the OH added in a Markovnikov faction. So we ended up with a product that looked like this, right? After tautomerization. In hydroboration, oxidation, we add the OH to the least substituted carbon. So it adds in a anti-Markovnikov fashion, and it tautomerizes to create an aldehyde. So this is the final product, right? But after tautomerization occurs, we end up with a final product that looks like this. So hydroboration, oxidation of alkynes is going to create aldehydes. So remember, aldehydes are just these molecules. And then hydration of alkynes is going to create ketones. Alrighty. So I gave some nomenclature problems to the SI session that happened last Thursday, and I'm going to give those out right now. And I'm not going to solve them just because I think with nomenclature it's best if one learns to think about it before someone else solves it. And after I give you the name, then it becomes pretty clear how to solve it. So I'm not going to like give a walkthrough of how to solve these nomenclature problems. But again, I would highly recommend that you stop the video whenever you want to. Right? So this right here is going to be 5 bromo, 6 methyl, jeez, 6 methyl, 2 heptene. Right. So that is that. And now number 18. It's going to look like this. And this is going to be 4-butyl, 3-octene. Okay. Now 19. And if you do actually need help on these problems, I'm more than happy to help. This is going to be 2,5,8 trimethyl 4 nonane, or nonene, because that's an alkene right there. And the last problem for our fresh SI session is this. Pretty simple. And this is going to be 2,5-octadiene. So thank you guys for watching. Again, I apologize for how messy I wrote the reactions, and for any other mistakes I made. If you have any questions, please feel